Here we'll learn about two different types of friction, static and kinetic, and how to calculate their magnitude. Look closely at any surface. You'll find tiny ridges and bumps which catch on each other. Friction is the force that opposes the relative motion between surfaces and objects. Friction can be classified as either static or kinetic. If the two objects or surfaces are not moving relative to each other, the frictional force between them is static friction. Say, for example, you try to push a heavy sofa across the floor. You push with all your might, but it won't budge. Static friction opposes the sofa's motion, acting according to the coefficient of static friction between them, represented by the Greek letter mu. The coefficient of friction always lies between 0 and 1, and it has no units. The maximum static friction can be calculated by multiplying μs, the coefficient of static friction, by n, the normal force exerted by one surface on another. The normal force pushes against an object placed on a surface, preventing it from falling through. The static friction force, Fs, and the normal force, N, are directly proportional. Now let's compare this to kinetic friction. When the two objects are already moving relative to one another, there is kinetic friction between them, the magnitude of which depends on the coefficient of kinetic friction between the surfaces. This can also sometimes be called sliding friction. The calculation is μk, the coefficient of kinetic friction, times n, the normal force. Again, in this case, the force is proportional to n. The specific values of μs and μk vary depending on the nature of the surfaces. But the coefficient of kinetic friction is always less than the coefficient of static friction. That tells us it's easier to keep an already moving object in motion than to make a static object move. Say you try to drag this box along the floor to the right. The direction of the frictional force is always opposite to the motion or impeding motion. So the direction of the frictional force would be to the left. When a force is applied that is smaller than the force of static friction, the friction opposes it equally, so the object will not move. As increasing force is applied, the static friction increases linearly with it. That is, until the maximum value of static friction is reached, at which point the applied force exceeds the friction and the object begins to move. Here's a practice example for you to try. An object with a mass of 2 kilograms is pushed across a surface. The coefficient of kinetic friction is 0.4. Can you calculate the force of kinetic friction exerted on the object when it moves? This force can be calculated by multiplying the normal force and the coefficient of kinetic friction together. We haven't been given the normal force, so step 1 is to calculate it using the mass, m, and the acceleration due to gravity, g. N equals m times g. So the normal force equals 19.6 newtons. Now we can calculate the kinetic friction by multiplying the normal force, 19.6, by the coefficient of kinetic friction, μk. The force of kinetic friction is 7.84 newtons. We hope the concept of kinetic and static friction is clear. There are plenty of practice questions on our website. Subscribe to our channel for more videos like this.